Hello everyone, I'm John from China IC team. Today I'm gonna show you a tool written by myself for simplifying operations of L3vpn inter-access. I'd like to start with the background of this tool. The development of this tool is based on the requirement of one of our banking customers using MX104 as their PE routers. Their networks, such as production, testing, management, are isolated via L3VPN. However, some addresses need to cross the VPN to access each other, and such requirements are changing frequently. As the network operators are always asked like this, management network 10.0.0.0 and the production network 11.0.0.0 need to be inter-accessible. To fulfill the task, the operators need to carry out lots of operations, such as confirm whether the network VPN belonging was right or not, find which router advertised the network, create a community SRT, config prefix list for the network, and modify import-export policy in corresponding VPNs and routers. What's more, the operations could become more and more complicated with the increasing number of routers and VPNs. To simplify this, I think we can leverage automation to do these jobs. Just input the requirement and then the configurations will be generated and pushed to related devices automatically. To put my idea into practice, I designed a framework of the program like this. The operator inputs the name of the VPNs and the routers and the networks which need to be interconnected. Then the Python script will compile this information into configuration and push it to related devices by PyEZ and netconf. After the second thought, I realized that some restriction mechanism should be set up to check whether the user's input was right or not, and even to give some heads up to the operator. Therefore, I add my SQL database to store information from their network. To achieve this information, Python uses a library from PyEZ to connect to RR router, which has whole routing information. However, RR doesn't know the name of VPN instances, the name of routers, and their management address. To be extendable, I don't want the script to connect every PE in their network. So JUNOS commit script can be a good tool for collecting such information. I wrote a commit script and install it to each PE. When commit is executed, the PE will compile the info such as its management address, hostname, and VPN names into a file and send it to RR. The Python script only needs to communicate with RR to gain all information. At last, I add PHP to read my SQL database, which can show infos to web page, and use a library called PHP Python to invoke Python script as the user clicks some buttons in web. Okay, that's the introduction of the program. Now let me demonstrate it. We have three routers in IC Lab connected as a triangle. Two MX5 named Beijing MX5 and Shanghai MX5 as PE routers, EX19200 as RR. Four VPN instances have already been created as production, test, manage, and video. Now let me open the page in my laptop. By the way, I named the program as Interstellar as the movie inspired me to create this program. As you can see from left to right, there are three main windows: VPN elements, XVPN schema, and routes. They are empty since I cleared up the data before the demonstration. Okay, now let's synchronize the data. When I click the Update button, the program will connect RR for obtaining the roles and the files we mentioned before. You can see the logs and the progress here. Now we can see VPN and the routers in the network from the left window. And there are color icons for quickly matching their relationship. The triangles indicate VPN, the circles indicate router. From here you can see the managed VPN exists in both nodes, Shanghai and Beijing. but the video VPN just in Shanghai. And likewise, you can see Shanghai MX5 has 4 VPNs, but Beijing has 3. When I click the VPNs, the corresponding router will be highlighted, and so do the routers. You may have noticed that some rules will be displayed in the red window at the same time. These rules are what we call the candidate rules, which belong to selected VPN and nodes. And from the icons showing here and here, you can also get which VPNs and which nodes the network comes from. Next, I'll interconnect network 121.0.0 from main VPN located in Shanghai MX5 and a production VPN's network 112.0.0 located in Beijing MX5. Let me ping them now. And it's unreachable since there are no policies yet. First, we create an interconnect profile, and by just select the VPNs need to be interconnect and the related nodes, and we click the X connect button. You can see the X VPN schema was generated. It's the profile. When we check the schema, we can see the rules can be selected, and we just select the rules to be interconnected and click the travel button. Now the PHP will pass these rules and VPNs and nodes we select to the Python, and the Python compile this information to a configuration file and push the configuration file to corresponding devices. We also can see the logs here, and the progress is now 100%. If we check the ping result now, we can see the network is connected. Now we can see the configuration modified by the program by compile the rollback 1. Okay, we can see here is the changed configuration. Include the policies and the community and the prefix list. And of course, you can create many interconnect profile as you need, and stack them and click the rules you need to interconnect. If you check the interconnect profile we already pushed to devices, you can see which rules are already connected, and of course you can modify it and push again. If a VPN interconnect profile are no longer needed, just select it and click the revoke button. You can use the same command to prove it. You can see it now cannot be interconnected, and the related configuration were deleted and the database are cleared. Okay, that's the demonstration. Thanks for watching.